Welcome to Newton's Three Laws of Motion, presented in stop motion by David, Liv, Tristan, and Nadia. We aim to explain, in this short movie, all about the three laws that have been the basics of physics since about the 17th century. But before jumping straight into the laws, best to explain a little bit more about the man himself, Sir Isaac Newton. Newton was a born and bred Pommy and lived from 1642 to 1727. He seemed to have a passion for learning, and was a physicist, mathematician, astronomer, natural philosopher, and alchemist, just to name a few. In the words of Newton himself, he stood on the shoulders of giants, or, in other words, tweaked already existing ideas to perfect them and call them his own. Apart from discovering the three laws of movement, Sir Isaac ascertained that the motions of Earth and of the other things in space are ruled out by the same set of natural laws, and developed a theory based on observing white light splitting into the colour spectrum.
The first law is also called the law of inertia, which states that objects at rest will stay at rest unless an outside force acts upon it. An example of this would be a pencil sitting harmlessly on a table. Then a miniature elephant runs across and knocks the pencil away. The elephant is an outside force, affecting the movement of the pencil. Get rid of the elephant and the pencil will remain stationary. The other part of the first law states that if an object is moving in a certain direction, unless an outside force affects it, it will continue in that direction. Like when a car is moving forwards, but suddenly brakes, your body is thrown forward, not by the car seat, but because your body is still travelling at 100 kilometers per hour.
Now the second law, possibly the hardest to get your head around, and the hardest to find an example on. The equation for this is F equals ma, or the force equals mass times acceleration. To make a little more sense out of this, here is an example. When you push an object in a certain direction, it will accelerate in the direction you push it. The acceleration is directly proportional to the force. If you push twice as hard, it goes twice as fast. The acceleration is inversely proportionate to the mass. If the thing weighs twice as much and you apply the same amount of force, it will go half as fast. What a mouthful, but let's continue with the third and final law of motion.
This law states that every action deserves a reaction. So strange as it may sound, but when you sit on a chair or give a downward force, the chair gives back an equal amount of upward force.
Without this explanation, we would have no idea as to why we can lean against the wall without it falling down, apart from the wall is bigger than me and can hold me up theory. Together, the three laws of motion give us a better understanding of how and why the things in life work the way they do. So we pay a big thank you to Sir Isaac Newton for explaining that the falling object in the middle of the night didn't just fall because it could, but something actually moved it. This was another movie from Purple Elephant Productions. Like us on Facebook.